Last question, y'all. Are you excited? I'm not sure if a single one of you is going to watch this. If you did, give me a little shout out. Say, walk up on the test day, say, hello, Mr. Weber. I watched that video till the end, and I thought it was quite interesting. Or you don't tell me what you thought. Should give you a secret code word. Here we go. I've gone over this before with one of my classes. So let's talk about it. We got a graph right here of we got an equation of a polynomial, and we got to sketch a graph. That's part A. So first thing to do, hey, I got an axis. First step when sketching a graph, what are the zeros? All right, we look at this. We say, what do I have to plug in for x to get a 0 here? That's going to be -1/2, because you multiply it by 2, that gets rid of that 2 down there, and then you're left with -1 to cancel it out. This one, you had 2, right? 2 minus 2, 0. This one, 3. And you've now got your zeros. That's the first big step of that. Next, I'd probably go, how about end behavior? Well, what the heck is end behavior? End behavior is asking what happens. All right, remember this is the x-axis, this is the y-axis. What happens as x goes all the way to the right? Becomes a really big positive number. What happens to y? Well, I'm going to look at this, and I'm going to go, okay, I put in a really big number for x. That means that this little part of it, that's going to be positive. I put in a really big number. That -2 doesn't make a difference. I put in a thing here that's going to be positive. Same here, positive, and it's going to be a positive squared. Don't forget this little -2 out front. So I got a negative times a positive times a positive times a positive times a positive. Yikes. But what you know is everything else is positive, and then there's one negative multiplied. One negative flips the sign, throws everything off. And so end behavior, as it goes all the way to the right, it's going to go down. What about all the way to the left? Technically, you don't need this step of end behavior, but you will need to know both of it. Oh, I didn't mean to write that. You will need to know both of it for the final problem of this. So here we go. We plug in a big negative number. All right, 2 times an enormous negative number, the +1's not going to matter. So this part's negative. This part is going to be negative, right? Because it's just a -2. The x becomes the biggest thing. Then this part is a negative, but it's a negative squared. And then we have a negative right here with the -2. So we ask ourselves, what is a negative times a negative times a negative times a negative times a negative? Yeah, that's too many. All right, match them in pairs, right? We got a pair right here, negative times a negative. All right, we can say that's a positive. This one right here is a negative times a negative in itself. So that's a positive. So we only got one more negative. In the end, it results in a negative. And hey, if that seems insane to you, if your brain does not work like that, try plugging in a really big negative number to every x and see if it comes out as a giant negative or a giant positive number. You got a calculator. Use it. So here we go. We got that. That's a great part of it. This is also the answer to part C right here, just so you know. All right. Now the last thing. Look for multiplicity. What does that mean? Multiplicity is the exponent on a factor, right? Exponent on a factor. So if we see an exponent of more than 1, so 2 or higher, alarm bell should go off. Wait a second, that one's got a 2. And so all that means is when we hit that 0 at 3, rather than, so this is 3, rather than going through, nope, the line isn't going to go through. That line is going to lightly touch it, give it a little kiss, and back off. All right? Yeah. So the other ones we know are going to go through, and we use this knowledge to sketch the graph. So we start with the zeros. There's a 0 at -1/2, right? Let's say this is -1. Bam, there's a 0 right there. 2, 1, 2. Bam, there's a 0 right there. 2. 3, 1, 2, 3. 1, 2, 3. Bam, there's a 0 right there. What happens as we go all the way to the right? Well, we go all the way down. So we got something like right here. Where is there multiplicity? Well, there's multiplicity at 3. We already talked about that. So as this goes here, it's not going to go through this. It's going to give it a little smooch, back off, and then it will turn around so it can go back through that 2, right? Because we know we have to touch that. We've already marked it as a point. Then there's nothing else. It's got to turn around again, and it's got to go through that 1. I shouldn't. Stupid thing. All right, it goes through it. It goes back. It goes through the 1. Turns around again. Goes. Oh, wait. No, there wasn't a point at 1. That was my mistake. Ignore me. The zeros are 3, 2, and -1/2. The reason I caught myself right there was because I know the end behavior should go down as well. So, right, as we go through the 2, we only turn around to come back through the -1, and then it goes down. So this, I'm going to make this cleaner. This is the shape of our graph, where it touches it only at 2, 3, and -1/2. Those are our zeros. And we got clear end behavior and all that. B, it says name all the horizontal and vertical intercepts of the graph. Well, that's pretty easy. Horizontal, that's the same thing as my zeros. So, horizontal intercepts, that happens at -1/2, 2, and 3. Now, vertical, that's a different one. That's right there. What does x equal when we touch the y-axis? Well, if we're right here, we're not in the negative territory, we're not in the positive territory, we're right at 0. So we can look at this equation, ask ourselves, what happens when x equals 0? So let's do it right here. We got g of 0, let's say, because we plugged in 0 for x, equals -2 times 2 times 0 plus 1 times 0 minus 2 times 0 minus 3 squared. All right? This is -2 times 1 times -2 times -3 squared. This is +9, -2, 1, -2. I shouldn't have put a parentheses there. So, -2 times -2 is +4. +4 times 9 is 36. So g of 0 equals 36. And so vertical, we write 36. There's other ways to figure it out, but that's how it works for me. And then C is state end behavior, which we already did. It's right here. This is problem C. All right. Best of luck on the test, y'all. All right. If you want any clarification, ask me first thing tomorrow, and have a great Halloween.